This just arrived last week. It's another T5 LED sort of fluorescent type fixture. Well, an LED fixture, but styled as a sort of T5 link light. And if you guys recall, I've already opened one of these, and to show you the one that I opened already, it's this, and I get the feeling it's going to be pretty similar. And it had a little buck regulator inside. Quite neat. So I'm wondering if the circuitry is going to be the same for the smaller ones. The other one had a diffused cover. This one has a clear cover, which is interesting. So let's try it out first. Let's check it's earthed. This came from eBay again. Everybody just always ends up asking. It came from eBay from Irresistible, and it was £3.59, which would equate to about, hold on, what would that equate to in American dollars? My second biggest viewer market times 1.5, roughly, that's about $5. It's quite odd how the analytics of YouTube break down. Some weeks it's the UK that's ahead, and some weeks it's America that's ahead. And the one thing that's clear is that that YouTube analytics, they base it on the minutes watched. And I get the feeling a lot of the American viewers are quite loose with the remote control. They jump backwards and forwards through videos all the time, whereas the British viewers are probably more likely to actually watch them all the way through. Then I think it's odd. It's Canada, Germany, and Australia, I think, are the other primary viewing zones. So let's now this wire for a start, it's got the feel already, and this is similar to the one I got last time. It's pretty much identical to the one with that. That the wire is probably coated, copper coated. It looks copper, but it's probably coated aluminium, and it doesn't feel like copper. So I'm just going to shove that in there, and I'm just going to check. I'm going to check that we've got continuity between the earth wire and the metal case, which, if I recall, was just a sort of contact stabbed on last time. So we do have continuity. That's good. So let's try this out. I should actually check what voltage this is, but I think it's pretty much universal voltage. I'm not 100% sure. It was supposedly 220 volt. I have not tried it yet. So let's plug this in. We'll plug in the power meter as well. And bring it into shot. So its power is 4.8 watts. Let's say 5 watts. 4.6 watts. It's kind of settling down. 4.5 watts. I think it will settle for 4.5 watts. Touches it gingerly. A nice warm white, slight pinkish warm white. That's quite a nice light actually. Right, okay, that's enough. Let's open it. Before anybody asks, because people do keep asking, this is the Cliff Plastics Quick Test. I think it's Clifford Plastics? Yeah, one of them. It's Quick Test unit. But it seems to be kind of aimed. They don't do an American version. I don't know why they don't do it with American. I'm not even sure what the American colours are. I think it's black and white, isn't it? I'm not 100% sure. But they just seem to do it in the standard sort of European flex colours. Those units are quite often used for connecting TVs. Well, it used to be in the old days with the high voltage cathode ray tubes. They used to be used in workshops for connecting TVs into isolation transformers, things like that. So this light comes with the little mains inlet lead. It comes with the clips that it snaps into, and it comes with this joining bit. But you know what it didn't come with? It didn't come with blanking plates, so you can actually poke your finger in there onto live contacts. Oh well, interesting. Yeah, the other one came with a blanking plate. Oh, not to worry. Oop. So let's open this up. It's held by this little... the last one was screwed in. This one is just clipped in. Which makes it very easy to take to bits. He lied, as it just completely failed to come to bits. Oh, that'll be the friction of the contact, maybe? Oh, much, much smaller power supply. That's interesting. This one is printed circuit board, this one is aluminium. That's kind of interesting. Rightio, off comes the other end, which is covered with a sticker, the test sticker, which I'm going to have to remove. Oh, it ain't coming off easy. There's the little plastic dimple I want to press. Oh, get out! Oh, it's not for coming out, is it? There it goes. And chop. What we got? Oh, right, okay, I could have just, oh, I hope that was oh. Right, this one's crimped, this one's not crimped, so that it kind of loses a point for the fact that this uncrimped cover over the wire was just rattling around inside the enclosure. I didn't actually check. That might have been neutral to earth, or it might have been live to earth, but more interesting here. Let's take a look at this. Now, how are these wired for a start? I could actually just test the voltage. I wonder if this is wired in multiples of 3. I have a sneaky feeling it is wired in multiples of 3. Should I measure the voltage across it? Yeah, let's power it up and measure the voltage across it. I'll just use these leads since they're so convenient now. Conveniently exposed. Even that wire feels a bit kind of like odd. I think they've definitely gone the economic wire route. I suppose ultimately if they can coat copper onto aluminium, I'm not sure what's involved in that. Do they coat it? Is it a chemical process that they coat it on, or is it some sort of sputtering process? I'm not really sure. Do they coat it on, or is it? I'm not 100% sure at all. It feels very floppy. So let's power this up. And get the meter in, and we'll set it for, let's set it for about 200 volts to play on the safe side. And then I shall book about here. 15 volts. Okay. That's interesting. So, I'm guessing this might just be a standard little switch mode. You know, one of the little switching regulators you find inside the typical compact fluorescent, not compact fluorescent, all over the place tonight, aren't I? One of the typical GU10-ish type lamps, but there's only one way to find out, and that's to open it. So let's cut towards my thumb, because it annoys those people that like to say, cut to your chum, not to your thumb. No, I just like cutting wherever I like. Oh, it is one of those, it's the typical, I'll just short that out while I've got this here. Actually, I find when you're cutting, I find that if you're cutting towards yourself and you're gripping, if you're just going, then yes, there is a chance the knife would slip. But when you're cutting towards yourself and you're regulating the flow and in a manner that it can't really slip and go anywhere, it's kind of safe. They just have to, I mean, MD who's used a Stanley knife will know that it's very easy to impale yourself with them. They make a nice job of slicing hands. So what we got here? Hot chip HT91223A. Is that a 3? I think it's a 3. Or is that HT91225A possibly? It's a kind of like blotched a wee bit in the package. So it's a typical little, it's got the rectifier, it's got the switching chip, it's got a smoothing capacitor, usually about 4.7 megafarad. It is 4.7 megafarad, 400 volt. Then it's got a little switching transformer and usually a tiny little capacitor, the other side, yep, and a rectifier diode, that side. It's a run-of-the-mill sort of 3 wattish type of driver, but they've possibly just cheated the power a little bit up by combining, I'd guess, 5 LEDs in series. One way to find out. Let's put this to continuity and see where the circuits are. So I'm guessing that these will just be connecting. There'll be a couple of bus bars going down the side, Could be wrong here actually. I may be wrong about, they may actually be doing that skip where they actually oh right, how have they got this done? Am I just not getting a contact here? Okay, I think I just wasn't actually going in with the point right into there. So the positive is connected to the end of that LED, and that one, and that one. Oh, I'm getting it now. 4 LEDs, and then the output of those will probably be going on to the next 4. Yeah. So they're doing that trick again, whereby the first 4 LEDs, they've effectively, it was about 15 volts across it, so they've got it wired as 4, 4, 4, 4. So they get 5 circuits of 4 LEDs, and each of those 5 circuits has the LEDs seemingly in parallel. That's why I wasn't getting a reading before. I wasn't expecting that, and yeah. Oops. Or actually, oh, they actually run down as loads of thin circuits? Yeah, that's interesting. I'm going to have to doodle this out. I think it's straightforward, I'm just not quite... Oh, you know what, it's just because of the angle I'm going in here. Right, so those things, they've got these LEDs wired as 4 in parallel. So 5 circuits of 4 in parallel wired in series across that power supply, which gives it the roughly 3 volts each. Let's see, 1, 2, 3, 4... 5, 3, yeah, that would have given the 15 volts. So yeah, they've done that presumably so that it's split along the length. So if an LED goes down, you're not going to, or goes open circuit, you're not going to lose a section. It just probably makes it simpler. I actually thought there was going to be a bus bar going down, but having said that, remember that this goes into a little guide rail. So if they can't have the guide rail shorting onto a track at the side, and it's on this malleable, strip here. I do like these cases. This presumably slides off just like the other one. I like these. They're quite thin, but they're quite a smart aluminium housing. If you recall the other one, I actually just stuck a bit of 12 volt LED tape in before. But it's interesting to see they've used this little supply. I quite like that actually. I quite like the fact they've. I mean, I think I prefer this approach to the big regulator like that. Although this one is obviously limited to lower power applications. But yeah, it's quite neat actually. I quite like that. So now I've put it back together minus the connection up to this end, because I've actually tried this in the kitchen. It's quite an impressive light. I tried it in place of an existing 13 watt fluorescent light, and I thought this did a very good job. Very good indeed actually. That may actually be going into the kitchen. However, the instructions are quite handy because they're entirely in German. Not sure why the instructions are in German. It's impressive. Handy if you're German, but I'm not, so we don't need instructions though. So this is how the lights are wired inside. The actual strip does have a sort of bus bar system down it. So you get plus and minus in and plus and minus out. So it's kind of designed that you can tack them end to end, but you'd have to increase the current availability. So at the moment it's using one of those little 300 milliamp drivers. If you did just tack 2 end to end, it would just mean that it would run at the same power, but the current would drop down through the LEDs. But at the moment they've got the 4 LEDs in parallel in each section, and then the 5 sections wired in series to make that up, which does 5 times 3 comes up to the 15 volts we measured. So looking at the wire is this strange, it seems to be copper coated aluminium, and just out of experimentation I double checked for a start. It was when you strip it, it feels springy. Normally with copper, when you spray the strands out, they stay put. This goes boing, and it just kind of goes back. But let's see if you can catch this. I'm going to do the flame test again. Try not to set fire to the iPad in the process. And lots of smoke may off them, and they're just sizzling, and they're just folding up and flopping down. So definitely not solid copper. Also going quite crispy. However, when you get a bit of solder and you flow it on, it's definitely a copperish coating because it takes solder nicely. It takes it absolutely fine, in fact. So odd. I mean, I suppose ultimately you get the best of both worlds. If it is aluminium, you're going to end up with lighter, cheaper, thinner cable. Well, thinner, it's going to be the same thickness really, but lighter, cheaper cable. And if they actually manage to copper coat, how on earth do you copper coat aluminium? But if they copper coat the aluminium, that gives you the best of both worlds, because it's the coating. It's the fact that aluminium oxidises in the outside that is the main problem with aluminium conductors. You have to take extra care to seal oxygen away and use compatible metals to avoid that corrosion effect that results, well, aluminium oxide is quite a high insulating factor. It causes major problems for their welding. Yeah, it's interesting stuff. It seems like a good solution, the copper coating of aluminium, if there is really a copper shortage in the first place. Or just as a cost-saving measure, since I'm guessing that aluminium is going to ultimately be cheaper than copper. But interesting stuff.